Okay, we're on Project I, Math 122. It's about running Sage as it relates to what you're doing in Math 122. Um, just to read over this says, writing doable problems is challenging. Then again, writing tricky problems that behoove even the best students, teachers, is all too easy, and it's true. It's really easy to write tricky problems. I wouldn't be overwhelmed by that. Like you look at something, I don't know how someone does this. Well, they have they may have some knowledge that you don't have about the problem. All right. But the bottom line is we give questions that are doable. All right. So this is a question about a series, and just to briefly go through it, I think most people looking at this, there's a couple of different ways of getting a series of this. One is you could try the long division, you could try using differentiation, yada yada yada. But I'll be honest with you, it gets to be tough. At least I felt it to be very tedious to do, paper and pencil, by either taking derivatives or by um, or by using a long division. But you'd get something like this over here if you went through the work. All right. I also want to point out you could use Sage. If you notice the footnote over here, I'll go to the bottom of the page. It says you could use Sage to generate that same thing. But again, it's sort of like the black box. What's Sage doing? And I'm not a programmer, so I really don't know what Sage is doing. But Sage is open source. You could actually look at the code and find out what the code is for Taylor. Now, it's probably based on a legacy code dating back, decades. I mean, certainly it's well-known algorithms for generating series. But anyway, I want to go through what I would look at this over here. And again, these problems are written to reflect this. And the first thing I did was, I differentiated something that looked sort of like that, and I got this one over here. All right. Then I started to realize, well, gee, this is an easy series to generate because it looks like a geometric series. And we go through that. I go through the work over here, talk about the geometric series, we know where it converges, yada, yada, yada. And I get a formula for it. And then what I do, I have to differentiate it. Let me point out what I mean by that. I have to differentiate this to get the series that I want to get. And that's what I did over here. So I got this series over here. Now again, this is you yammering on about all the work that I've done. The critical thing is you need to go through the work. You need to match this up. And this is probably one of your biggest struggles in life. When you're in an academic program, particularly STEM, getting through one or two pages of work could take days. All right, it could take days. Now, hopefully over time, days become hours, and hours become minutes, and minutes become seconds, all right, for certain materials. Some material, no matter how you look at it, is going to take a long time to get through. I would say this took me time to get through. It's going to take you time to get through, all right? But anyway, I get a series for it by doing some handwork, and I get a interval of convergence over here. Now, what I want to claim over here, just looking at the Sage code over here, what I do is I generate a series for this using Taylor, but I want to see if the series that I'm getting, by the way, which is centered at 3 over 2, if the fifth degree polynomial over here is identical to what I got over here, right over here. So I had to type that up. I'm using Boolean, and I'm using Boolean to see if it's true, and it does say it's true, all right? So the other thing I want to point out is, let's say I want to go a little bit higher than that. Let's say I wanted to go not to 5, but to 10. I can do that, and I type that code in here for you. Oh, by the way, this graph over here is 99 terms, and I'm using Grapher to do that. Someone says, why don't you use Sage to do that? I'm not that great at using Sage as a programming language, and I notice that when you get to 99 terms, Sage is sort of struggling with the graph of it because it's seeing things that are growing very rapidly over here and over here. And it's true, they are growing very rapidly at that point. Grapher has no problem with it. Grapher is commercial software, whereas Sage is not commercial software. And again, I'm not that much of an expert in doing it. I use X lower bound, X upper bound to get the bounds of the problem. Why do I use this over here? Because I already figured out the interval convergence, and I'm saying these are the bounds of my graph. And so what I do over here is I graph it out for you, and I plot it, and I get a nice looking graph. Now, this is only to degree 10, but the bottom line is over here, I did the degree, I think it was 99 or something. Yeah, it's a large degree. Here's the deal, though. Your mileage may vary. So what do I mean by this? When you type this code in, I'm hoping you're able to do this as well, all right? Now, again, I think I've typed enough code in over here, but I do want to remind you to launch Sage. Multiple ways of doing it. You could launch it as an application. If you do launch it as an application, if you're using it often enough, it's probably going to be in your dock. But if you're not using it often enough, go to the Finder, go to your applications. Just give me 1 second here. Let's see what I got. Application, sorry about that. Sage Math right over here. Double click it. What is it going to give you? It's going to open up whether you want to use Terminal or Jupyter Notebooks. Up to you. I use Terminal. But again, if you're sharing your document, you're going to have to use a Jupyter Notebook. I'm going to use Terminal though. Launching it. And Sage will open up. I'm running 9.4 right now and Python 3.95. And again, what you do is, oh, by the way, I said Sage running already. Let me close that out though. You type this stuff in, all right? Again, I want to warn you against the copy paste, all right? So a lot of students, what they do is I copy line by line. I want to warn you against that. For example, I copy this line over here and I type it in, I get an error. By the way, it points out the error. The error are in those quote marks, and I'll just retype the correct quote marks. Yes, some people can't see the difference between the two, but there is a difference between the two, all right? Now that would be the correct thing. And again, copy paste. I put on what I mean by this. If you want, this is a little more difficult. Copy paste this. This is a Boolean. By the way, you're not really learning by copy pasting, and that's a problem for a lot of students, that everything's a copy paste. There's no reading, and that's not good. All right. I hope I copy paste right. Yeah, true. Came out okay. All right. You get the idea. So this over here, again, my expectation is you read it, look at the code, try to see how it relates to your paper and pencil work for project letter I in Math 122. Again, I really appreciate you paying attention to this. Again, if you have any comments or concerns, please try to touch base with me. And I say, eye to eye is probably the best way, or face to face is probably the best way to do that. Again, thank you.